Right. So we're doing carbon and its compounds. This chapter is going to be all about carbon. So abhi tak, if you've seen, your first chapter, chemical reactions and equations, had basics of reactions. And then you studied all about acids and bases, acids, bases, and salts. What kind of substances they are, how do you identify them, and what kind of reactions they will undergo. Then you had all about metals and non-metals. What are metals, non-metals, how do they react, and how, like metallurgy also you had, which we did not study in the previous chapter. Now, this chapter is going to be all about carbon. In fact, carbon is a very, very important element. It forms the basis of all life, which is why it's called organic chemistry. So the name organic comes from the fact that, like organic and living organism have the same origins, like they're connected. So basically, organic chemistry is initially, it was thought that, like all the carbon compounds, like your carboxylic acids, hydrocarbons, all of that was connected to living organisms only in some way. So that's what organic chemistry is all about. And it was found that carbon is the main element that forms the basis for all of life. So any living thing that you take, any tissue, cell, DNA, anything connected to living organisms you take, it is made up of carbon compound. Okay, so you have like network of carbon atoms, and then like of course you have your hydrogen and oxygen and nitrogen and phosphorus and other things, but carbon is like the backbone of all cells and tissues and all of that. Okay. Hi Shakti, were you saying anything? Were you saying something?
No, ma'am.
Okay. All right. So that's where organic chemistry comes from. And anything that is derived from living organisms, like petroleum. Do you know how petroleum is formed in nature? Like where do we get coal and petroleum from?
Fossil fuels.
Fossil fuels, yes. Coal and petroleum are fossil fuels. And where do you get fossil fuels from? Like how are they formed?
They are very deep under the ground, and they are formed over many years of compression of animals and plants that were hundreds of years ago.
Correct. So even coal and petroleum, even if they're like completely non-living things, they seem to be part of the earth. But if you look at their origin, they come from living organisms. When living things, old plants, animals decompose, they decompose, and then eventually, because of the temperature, pressure, all that conditions, what you end up with is the hydrocarbons, which is basically your petroleum. Okay. So organic chemistry is really important. If you look at different aspects in your own life, not just yourself as a living organism, but paper. Again, paper is made from trees. Trees are living things, so that's again organic substances. Plastics are also organic substances. You take an organic compound, like a carbon-based compound, and then you treat it in a particular way, and what you end up with is different types of plastics. So depending on which compound you start with, you get different plastics, whether it's PVC or whether it's Teflon or whether it's melamine, like whichever it may be. So organic chemistry is really important, and it's a completely different branch of chemistry. When you do chemistry at higher levels, like graduate chemistry, and even in 11th, 12th, organic chemistry is like a whole different branch that you have to study in a different way itself. The logic behind it, how to understand and interpret, all of that is very different. Coming back, like in 10th standard, carbon and its compounds is like your first step towards organic chemistry. It's like an introduction of sorts. It is going to be kind of different from the previous chapters that you studied. So in both acids, bases, salts, and metals and non-metals, the pattern was pretty much the same, right? Like you had first a little bit of introduction about what they are, and then you had reactions related to them. How do acids react with metals? How do metals react with water? How do acids react with base? How do metals react with, other substances? The pattern was pretty much the same. You just had different reactions in different situations. But when it comes to organic chemistry, yeah, you will have reactions, but the mechanism of how do you figure out those reactions, and also how do you identify different compounds, like the whole thing is different. You have to approach it in a different way. Okay, so before we start off with the chapter, you need to know some things. First thing, do you know what is the structure of the atom, like how atoms are made? Do you remember that?
Electronic configuration.
Electronic configuration and general structure of atom.
And the neutrons, protons, electrons, which orbit around the atom.
Oh,
Neutrons and protons are in the nucleus and
Yes, and the
electrons are
nucleus
outside
and the
in the
electrons
shells.
orbit around the atom.
very good. Neutrons, protons in the middle, and electrons orbiting outside. Abir has sent 2, 8, 8, 18. Okay, that's good. Like there is a distribution of electrons. That is correct. Do you know what are valence electrons? What do you mean by valence electrons?
Electrons are
the last
Electrons in the
shell.
outermost
shell.
shell.
Last shell, outermost shell, whatever electrons are there, they are valence electrons. Very good. Metals and non-metals we have talked about ionic bond, how ions are formed, and the compounds formed from ions happen because of an ionic bond. In contrast, there's something called covalent bond. So what do you mean by covalent bond?
Sharing of electrons.
sharing of electrons.
Yes, Abhi? Yeah, Abhi, what's up? And in case you're speaking, you're muted, so I can't hear you. All right. Okay, but yeah, Puneet, Ananya, yeah, what you guys said are correct. Covalent bond electrons are shared between two atoms. So it's like I give one electron, the other atom gives one electron, and that pair belongs to both the atoms. Okay, that's how octet is fulfilled. Do you know what all are the different types of covalent bonds that are there? Like, have you?
Yes, ma'am. Single covalent, covalent,
Ring.
triple covalent.
Can
I'm
you
like single covalent.
single bond? Yes. What other?
Ma'am, O2 is for double covalent bond.
Single covalent bond, double covalent bond, triple covalent bond. So difference kya hai single, double, triple mein? Like what happens in single bond versus bond?
In single covalent bond, only one electron is shared.
One electron is shared?
So it is shared with only one atom.
It's one pair of
Like
electrons.
in H2O.
That is correct. Yes, one pair of electrons is shared, or two electrons are shared. So that details that you need to be familiar with. But yeah, it's a part of this chapter, so we will be doing that. We'll get into the details of that. But yes, so 3 types of covalent bond. You have single covalent, you have double covalent, you have triple covalent. So single में क्या होता है? So there's one pair of electrons being shared. Double covalent में क्या होता है?
Two pairs.
Two pairs of electrons.
Two pairs, correct. So 2 pairs, or in total 4 electrons are shared. And triple covalent bond में
3 pairs.
or a total of 6 electrons being shared. Okay, so this is an important point. Covalent bond में हमेशा you have electron pairs. So talk about electrons in pairs. It's 1 pair, 2 pair, or 3 pairs. Okay, so that's like an important thing you need to know. All right. Yeah, so these are the basics that we need to know, and then we can jump right into the chapter. Okay, so I said, okay, like first thing, we're talking about all about carbon in this chapter. Carbon का symbol क्या है?
C.
C.
C, that is correct. Atomic number?
12.
Atomic number?
6.
4.
Oh,
No, 6.
I'm
The
6,
2, 4,
sorry.
so
Yeah.
6.
atomic number is 6.
And 4.
That is,
Electronic configuration.
yeah. So, which means that atomic number 6 का मतलब क्या होता है? Like how many protons and how many electrons does carbon?
6 proton,
It
6
is
electrons.
4.
6
6
protons and 6 electrons.
Protons. Neutral होना है, so number of protons should be equal to number of electrons. So 6 protons, 6 electrons. And mass number क्या है? Like what is the atomic mass of carbon?
12.
12.
It's correct.
Ma'am, it is 12.
Yes, which means that carbon also has 6 neutrons. Okay, so protons and neutrons in the nucleus and 6 electrons revolving around the nucleus. So what is the distribution of these 6 electrons? What is the electronic
1, 2,
configuration?
and 4.
2, 4 in the valence.
Very good.
1, 2, 4.
So electronic configuration is 2, 4. Okay. So this is what carbon looks like. You have the nucleus, just may you have 6 protons and 6 neutrons. Then 2 electrons in the first shell and 4 electrons in the outermost shell. Valence. So 4 is the number of valence electrons that carbon has. So what is the valency of carbon? Agar octet
4.
4.
4.
valency will be 4. Okay. So in order to get octet, either like what should carbon do to have a noble gas configuration?
You
Share
can give
electrons.
4 or
It can break.
So हमारे पास like so far based on what we've learned, atom will either give electrons or take electrons, or it can share electrons, whichever is easiest for that particular atom. Like if you look at sodium ka configuration, who remembers?
11.
281.
281.
Distributed as 281. And because there's only 1 electron outside, it's easy for sodium to just lose 1 electron and then, get the octet configuration. Similarly, fluorine ka who remembers configuration?
27.
7. Yeah.
Very good. So 27. Fluorine is 9. So 7 electrons in the outermost shell. So it can just like gain 1 electron and get the noble gas configuration 28. Octet mil gaya, it's happy. So it's if it's like single electrons, that's pretty easy for an atom to handle it because single charge, unit charge has same single electron here. But when it comes to carbon, which has 4 electrons, what can it do? So let's look at each option one by one. Okay. So one is if carbon loses all 4 electrons. Loses 4 electrons, which means that if it forms
Highly positive.
C4 plus. Abhi, in order to form this configuration, it needs to lose 4 electrons. Okay. Now, taking an electron from an atom is not easy. Okay, you need to put in some energy to convert an atom into a cation. So, एक electron निकालने के लिए, it's easy in the case of sodium because निकालने के बाद whatever configuration you're ending up with is a stable configuration, something that the atom likes. But in the case of carbon, अगर एक इलेक्ट्रॉन निकालो तो then you get 2 3, one which is not a noble gas configuration, and two, it will also gain a positive charge. So अगर एक इलेक्ट्रॉन निकाला तो you have like 6 protons and 5 electrons. So in that situation, nucleus ka hold, will it be stronger or weaker?
Stronger.
It'll be stronger क्योंकि positive charge ज्यादा है. You removed one electron, negative charge कम है. So the 6 protons are able to have a greater force to attract the remaining electrons. So after removing one electron, will it be easy or difficult to remove the second electron?
Difficult because it is having more force towards the nucleus.
हाँ, अगर ज्यादा चार्ज है तो ज्यादा डिफिकल्ट होगा उसको निकालने में. Like you guys have played with magnets, right? So if two magnets are holding on to each other like really strongly, you need to put some force to separate that. So it's a similar thing that's happening. Proton positive charge hai, electron negative charge hai, opposite charges attracting each other. So removing that from strong positive charge is going to be difficult. So imagine if you had to remove 4 of those electrons. Imagine how much energy you need to put in for that. So is this like a good option for carbon? Do you think carbon will prefer forming a cation in that situation?
Ma'am, won't it be unstable also?
Absolutely. So 2 points. One is if it loses 4 electrons, you end up with 6 protons and just 2 electrons, which will contribute to it being like highly unstable. So in the first place, you need a lot of energy. So you need to like spend a lot of energy, or carbon needs a lot of energy to form a cation in the first place. And second point is, even if you somehow like just heat it up, you provide electricity, like somehow if you get this, you end up with an extremely unstable ion. Okay, so this method for carbon to get octet configuration is a bad idea. So carbon doesn't do that. The next option is like fluorine. Let's say carbon wants to gain 4 electrons and form an anion, C4 minus. Now, what will happen in this situation? So already 4 electrons hai. If carbon forms an anion, then what will the electronic configuration change as? Like how many protons and how many electrons will it have?
6 protons, 10 electrons.
Yeah, 6 protons and total of 10 electrons. So, like if an atom gains 1 2 electrons, like it's fine, because one, it's doing that to get the octet configuration, which the atom likes. Like that is something the atom prefers to have. So, because of that extra stability, it will accept electrons. But if it gains 4 electrons, one, this particular orbital is going to get extremely crowded, and having just 6 protons to hold on to all these extra electrons, that also makes the ion extremely unstable. Okay, so exchanging 4 electrons, whether it's gaining 4 electrons or losing 4 electrons, it requires a lot of energy changes from carbon's end that it's just not feasible. Like it's not preferable for carbon to form ions at all. So what is the only thing carbon can do in order to gain that stability, in order to get the octet configuration?
It will neither give, neither take.
It comes with some other element and form a compound.
Share it with some other element. Yeah.
Yes. So the only option left for carbon is share the electrons with other atoms. So if carbon ends up sharing electrons, what kind of bond does carbon form?
Covalent.
Absolutely. So carbon only forms covalent bonds. You will never find carbon in an ionic compound unless it's in the form of something like a carbonate ion or cyanide ion, or like in a polyatomic ion you'll find carbon, but you will never find carbon in a purely ionic compound the way you'll find like oxygen or nitrogen or chlorine. Like oxygen forms oxides, chlorine forms chlorides. That way carbon does not form any ionic compound. Very rare. Yeah, Shakti, what's up?
Ma'am, could you just switch to the previous page for a moment?
Yeah, I will. Okay. So carbon ends up sharing electrons and forms covalent bond. And valency is 4. So it should end up forming 4 bonds. Okay. So this is like a popular question and a popular, like it's an important concept in the basics of why carbon forms covalent compounds. So is everyone clear about this?
Yeah, ma'am.
Okay. All right. So anyone has any doubts, let me know right now. Otherwise, yeah, once you've noted this down, we'll go to the next part. Just to summarize, yeah. So carbon, in order to form ionic compound, the options are to either lose all of its valence electrons or gain 4 more electrons in the valence shell. If it loses 4 electrons, you require a lot of energy to take away electrons from the atom. So you require a high amount of energy only to end up with an extremely unstable cation. Similarly, gaining 4 electrons also, you end up with an atom or an ion which has only 6 protons, but that need to hold on to 10 electrons. Again, that's going to be extremely unstable. So that's why carbon does not form ionic compounds. Yeah, Ananya.
Ma'am, same happens with silicon because it also has configuration 284 or something else.
Yeah, like silicon also prefers forming covalent bonds. With silicon, so another aspect, that's a good question, Ananya. So with silicon, right, if you compare the size of silicon atom and carbon atom, is there any difference in their sizes? Like how do both of them compare? So silicon is 284, carbon is 24. And this is what silicon atom looks like. 8 electrons and 4 in the outermost shell. So what is the difference between a silicon atom and a carbon atom in terms of their sizes?
Ma'am,
Silicon is
carbon has
larger.
2 shells and it has 3 shells. It is larger silicon.
Yes, silicon is a larger atom. So when an atom is larger, like what do you think is the difference in the nucleus ka holding power? Like the nucleus's effect on the outermost electrons. Oh yeah, Mansi, yes. Silicon also would have more protons. Like carbon just has 6 protons and 6 electrons. Silicon nucleus ke andar you have 14 protons. So usually in
Compared in third shell, it will be less. Power will be less then.
Correct. Yeah. Now because it's a bigger atom, more number of protons, but because the distance is a lot more, the holding power of the nucleus is going to be less. So that actually affects the extent of, how reactive silicon is, and what is the, how easily it's going to lose electrons or hold on to electrons. That's actually an important property, which we'll be talking about in like when we do periodic classification. It's not just in the case of carbon silicon, but like every single element, as you go, like as you increase the number of shells, it's going to affect the holding power of the nucleus on the valence shell. So yeah, that ends up making those elements, like even though they have a bigger configuration, they tend to start behaving like metals. So that's why carbon is purely a non-metal, but silicon shows some properties of metal as well as a non-metal. That's why it's a metalloid. It's in between a metal and a non-metal. And then if you go below silicon, you end up working with osmium and lead, and titanium is over there. But yeah, like all of these elements, selenium, they start behaving like metals also.
So, ma'am, generally silicon forms covalent bonds, but does it also form ionic, because it also has metal properties?
In some situations, yes. Yeah, its covalent nature is not as much as carbon. It's like slightly lower than carbon, but it's not like, like metallic nature, non-metallic nature. It's not like a black or white thing. It's mostly on a spectrum. Like some elements are more metallic, other elements are less metallic. They trend towards more non-metallic nature. So that way, carbon exclusively covalent, silicon mostly covalent. A little, there may be ionic compounds. I'll have to look into that. I'm not very good with the inorganic chemistry part of it, so I'll have to like do some research on that. But yeah, the trend is that, yeah, silicon will form covalent bonds only, but there would be some cases, like extreme cases, if it's like a highly reactive metal or something, it is capable of forming ionic bonds. Yeah. So in that aspect, carbon and silicon are like really similar to each other. When we talk about catenation and all, also we'll come across that. We'll talk about it. All right, so you guys have noted this down. Can we go to the next part?
Yes, ma'am.
Yeah, ma'am.
Okay. Everyone? Elena, yes. Aditya, Neil,
Yes, ma'am.
Abhishek, Anisha, Deshna, Jaden. Done? Okay. All right. All right. I'll go to the next part. If anyone is still noting, stop me, okay? So yeah, we've established that carbon forms covalent bond. Now, you guys know the theory of it. You're aware that covalent bond there is sharing of electrons that take place. Always electrons are shared in pairs, like one pair, two pairs, or three pairs. That's how you get single, double, and triple bonds. Now we'll actually draw the structure of how electrons are shared. Okay. So just like how we looked at ionic bonding in the previous chapter, valence electrons lost, or electrons gained in the valence shell. Similarly, we look at how electrons are shared in between atoms. So this notation that you use to show on paper of how the bonds are there, how the electrons are shared, is called Lewis notation. That's called Lewis dot notation or dot representation. So it's called Lewis dot representation because the electrons are usually represented in the form of a dot. So you use either a dot to represent the electrons, or you use a tiny cross to represent them. Okay. So for example, how many electrons does hydrogen have?
1.
1.
So
1.
yes. So if you had to represent hydrogen atom as like in Lewis notation, you write the symbol of the atom and then you represent only the valence electrons. So hydrogen has 1 electron, that itself is a valence electron. So a single dot. Okay. So this is how you represent hydrogen in the Lewis notation. Coming to chlorine. Chlorine का symbol क्या है?
Cl.
Cl, capital Cl.
Capital
Cl.
small l. And how many valence electrons does chlorine have?
7.
7.
7.
7.
So you ignore, so when it comes to chemical bonding, by default, you just ignore the inner electrons, okay? So you only look at the valence electrons because valence electrons are the only ones that are taking part in bonding. So we don't care about the others. So the 7 electrons you can represent, I'll use crosses for this. And see how electrons are always represented as pairs. The 7th one odd number है, so the last one is single this way. Okay. Electrons are always present in pairs. Agar single electron hai, to yeah, nothing can be done. But as far as possible, always put electrons in pairs. You shouldn't put it randomly. It's not a design. It's, yeah, this is the convention because they exist in pairs. Right? So this is how you would represent single atoms. If you had to, if hydrogen and chlorine had to form a bond, they share the single, like the hydrogen shares its single electron and chlorine requires only 1 electron, so it's going to share its single electron. So the way you represent this sharing of electrons is write both of their symbols. If you figured out that दोनों के बीच में single bond होगा, तो hydrogen का electron इधर है, chlorine का electron इधर है. Now chlorine also has these remaining electrons, right? So just put that, all of them over here. So this is how you represent a molecule of HCl in the Lewis dot representation. So you can see clearly that there is 1 pair of electrons, matlab 2 electrons shared between hydrogen and chlorine. And you can also see acha remaining kitne electrons hai chlorine ke saath.
So ma'am, your electrons are shared, right?
Yes.
So this is also a covalent bond.
This is a covalent bond, yes.
But
So-
you said like carbon forms covalent bond, right? Here there is no carbon.
So carbon is not the only one that forms covalent bond.
Okay.
Carbon forms only covalent bond, but covalent bond you will find in like a lot of elements.
Ma'am, but your
Okay.
H had only 1 electron, so it could have given it easily, right?
So
No, but if it gave, then it won't exist only.
no, it still exists as a single proton, right?
It will become ionic then if it's
Yeah.
giving over there.
Yeah. So hydrogen does tend to share electrons. Hydrogen also gives out electrons. You will find hydrogen in ionic form usually in polar solvents. Like in water, you will find hydrogen existing as an ion. That's how you get your hydronium ion. But usually outside of water, like dry HCl gas or H2 gas, hydrogen prefers to do form covalent compounds. So there is a reason for this. But yeah, like coming back to HCl, yeah, this is how it is. You can see that hydrogen has fulfilled its octet. So pehla shell can take only 2 electrons. Hydrogen has got the 2 electrons, it's happy. And chlorine has got 8 electrons. You can just draw a circle to show that 8 electrons to chlorine, 2 electrons to hydrogen.
Ma'am, this is single bond, right?
Yes, single pair of electrons, single bond. So single bond is represented by single dash. So 1 dash represents 2 pairs of electrons. Sorry, 2 electrons, matlab 1 pair of electrons.
Even one element can share within its element, like hydrogen, two atoms, it can also share light.
Oh yeah, absolutely. So if you look at H2,
Then why doesn't carbon share?
carbon shares. Like, sorry, what was your question again, Puneet?
How will carbon share? Like
We'll come to
4
that.
and 4.
Yeah, we'll come to that. I'll take each one by one. Okay. Like abhi single bond dekha hai na. To figure out if something will have ionic bond or covalent bond, there is a format to it. So this is the case in like almost 90% of the cases. Like this is like the default. If the bond is between a metal and a non-metal, अगर कंपाउंड में एक मेटल है एक नॉन मेटल है, उन दोनों के बीच में इट इज ऑलवेज आयनिक. Here. And if the bond is between two non-metals, so if the bond is between a non-metal and another non-metal, अगर दो non-metal के बीच में है bond, then it's always covalent. Okay, so if you had to identify if you have a compound and you needed to figure out कि ionic bond होगा या covalent bond होगा, just see what elements there are. अगर एक metal और एक non-metal है, it's always ionic. अगर दो non-metal के बीच में है, तो it's always covalent. ठीक है. So only in the case of acids, that too, if it's like a pure acid, if it's a dry acid, then it's always going to be like a covalent bond. Only when you mix it in water, now because of the polarity of water and like other factors that come into picture, it breaks down into hydrogen ion and whatever anion is there. But other than that, everywhere else, like generally, if you take a pure compound, अगर metal और non-metal के बीच में है, that particular bond is always ionic, and अगर दो non-metals के बीच में है, then that bond is always covalent. So Mansi has asked a question. I was just about to ask you guys, what kind of bond will you find between a metal and a metal, between two metals basically?
Ionic.
Who said ionic? Is that Nikki? Shakti, okay.
No, ma'am.
Mansi said alloys. Rishita says it will be a mixture. Tanisha also says alloys. What is alloys? Like what do you mean by alloy? Like what do you know about it?
It's a mixture
It's a
of
homogeneous
Yeah.
mixture of more than two metals or non-metals.
Mixture of two metals. Brilliant. Or mixture is a physical thing or a chemical thing?
chemical.
Huh?
Physical, right?
Physical.
Physical. Like mixture में कोई bond, chemical bond form नहीं होता है. So it's a physical mixture. It's like making salt water except metallic addition. Like you're just mixing two metals. तो metal के atoms है. तो बीच में you have the other metal के atoms just chilling there in the structure. So it's a physical mixture of two metals. That's what alloys are. So why do you think metal और metal के बीच में कोई bond नहीं form होता है? So the answer is metal and metal.
Both are electropositive.
Very good. That is absolutely correct. Metal or metal के बीच में you will not find any chemical bond happening because metals क्या होता है? Like what is the property of metal? Like what makes metals as metallic?
Free electrons.
Free electrons. और free electrons कहाँ से आते हैं? Metals are metals.
Ma'am, then like this, how can non-metal and non-metal form a bond?
Because they share electrons. इसलिए non-metal
So why can't metals share electrons?
अगर metals को electron share करना है तो let's get into this. Wait.
They will need to share 4 or 5 electrons then, because they are in the configuration of always 1, 2, 3.
Absolutely. Well done.
Can you once more turn back?
So metals, can you guys give me some examples of metals?
Iron, copper,
Aluminium, iron, zinc.
Aluminium, yes, zinc. Let's not consider iron, zinc, क्योंकि उनका electronic configuration you won't be able to figure out right now. Or like, give me examples of metals जिनका
Sodium,
configuration पता है. Yeah, sodium,
Magnesium,
aluminium,
calcium,
calcium,
magnesium,
magnesium,
potassium,
potassium. ठीक है, 5 है. What's the electronic
Silicon.
configuration?
283 for aluminium,
aluminium,
281 for
281,
sodium, 288, 2 for
882.
calcium,
Yeah.
282 for magnesium.
Yes,
881 for potassium.
that is absolutely right. And what do you find common amongst all of these?
Last it was less than 4.
less than 4 electrons in
Four.
valence shell.
Yes. So that's like a defining characteristic for metals. Ki if there are less than 4 electrons in valence shell, then you can bet on it that that particular substance is going to be metallic in nature. Like that's the main difference. Like what divides metals and non-metals. हमेशा अगर कोई भी element लो, कोई भी atom लो, and then if there's less than 4 electrons, then it starts taking on properties of metals. Like इसलिए it is able to release electrons freely, like the electropositive nature, and that's where your conductivity, the shininess, all of that comes from, and then we end up calling it a metal. If there are more than 4 electrons, तो वो element ये सब नहीं कर सकता है. So we end up calling it a non-metal. So that's where that difference comes from. See? So if you take metal, अगर less than 4 electrons है, तो again same 3 options. Either it can lose the valence electrons or gain electrons to complete octet, or it can share electrons. So in तीनों options में से what will be easiest for these elements? Lose electrons. That is correct. क्योंकि gain मतलब 6 electrons gain करना है, तो that's like a lot. Again, the protons won't be able to handle it. And share करना है, if it only has 3 electrons to offer, it will share its 3 electrons, it will take 3 electrons, end up forming a triple bond. फिर भी 3 plus 3, 6 electrons ही आ सकता है उसको maximum. 8 electrons नहीं आ रहा है. Look at sodium. It has only 1 electron, which means it is capable of forming single bond. So you'll end up having only 2 electrons. So sharing also is not an option. It's not going to get 8 electrons by sharing this. Okay. So that is the reason why metals don't form covalent compounds or covalent bonds. Metals will only form ionic. That's why always metal or non-metal के बीच में ionic होता है. Because non-metal is the one that is capable of gaining electrons, forming anions, and you end up having ionic compounds.
And what about H2O? It is non-metal and non-metal, right?
Yes.
But it isn't a covalent bond.
H2O. Are you talking about water?
Yeah.
Water is covalent. That's a good example. So
Just what about 3 metals then? That will be highly reactive.
3 metals also, again, like metals just don't have enough electrons. Like if you have metal A, by sharing with 3 or 4 electrons, A will gain octet. But what about these others? इनको तो octet नहीं मिला ना. So that's why metals will always only lose electrons. And agar do positive charge, like if you have 2 positively charged species, like charges will attract or repel.
Ma'am, they will repel.
they will repel. तो दो metal ions के साथ भी कोई bond नहीं form होगा, because they're going to push each other away. Okay. All right, let's come back.
Ma'am, in ionic bond, ions are combining, right?
Yeah.
So it will be, in case of water, if we take an example, it will be H plus and O2 negative. That's why two of hydrogen and one of oxygen. So it will be ionic, because plus and negative we are considering, right?
Neki, you are logically right, but
Because
hydrogen,
like in carbon, we never say C4 negative or C4 plus when we are
absolutely.
taking.
Yeah, Neki, like logically, it makes sense what you're saying. But in reality, like somebody else also had mentioned this earlier when we were doing HCl. So hydrogen does not prefer turning into an ion because it has only a single proton surrounded by a single electron. So if it loses this electron, it's going to be a single proton just like floating in space. And single proton is not stable, like it doesn't have the capability to exist like as a single proton, which is why even in the case of acids, this single proton is going to attach itself to another water molecule and form this hydronium ion. You remember we studied this in acid basis salts. So water, like wherever hydrogen is concerned, treat it as a non-metal only. Yeah. Yeah, Shakti.
It's nothing, ma'am. It's from before.
Oh, acha, from before. Okay. No, I got a notification as if we did it.
That's why like hydrogen forms a covalent when it's happening on its own, like how I mentioned earlier about that.
Correct. Yeah. So whenever you have hydrogen, it's always a covalent bond. Hydrogen forms ionic bond only when it is bonding with a metal. Like you have compounds called metal hydrides, which are again formed under extreme circumstances, like high temperature and pressure chahiye iske liye. But and that too, it forms these metal hydrides only with like extremely reactive metals. You won't have it with iron, copper, zinc, and all. You'll only find sodium hydride, lithium hydride, like maybe calcium hydride. Yeah. Aluminium be kami, I don't. You have lithium aluminium hydride. And that's also, it forms under extreme conditions that it's pretty unstable. So you use these hydrides again when you want like fresh hydrogen in reactions and all. But otherwise, treat hydrogen as a non-metal only. Okay, so with other non-metals, with oxygen, chlorine, it forms covalent bonds. With metals, it has the capability to form ionic bonds. That's basically like a non-metal only, right? You have NaCl, you have NaH, sodium chloride, sodium hydride, that way. So treat hydrogen as a non-metal, and non-metal ke beech mein covalent bond hi hoga. So any molecule you find hydrogen in, it's going to be a covalent bond. Okay. All right, we'll look at some more examples with practice covalent bonds. You guys have already discussed this pehle, but oxygen exists as O2 molecule. So O2 represents, like, this means that there are two atoms of oxygen. So un dono atoms ke beech mein what type of bond will you find?
Covalent.
Covalent, yes. How many electrons would oxygen have to share? Let's figure it out. Oxygen ka configuration kya hai?
2 and 6.
2, 6.
Yes. 6 electrons matlab how many more electrons does oxygen need?
2 more electrons.
Need 2 more electrons.
So it will form a double covalent bond.
There you go. Agar 2 electron chahiye, so this oxygen, it itself needs to put out 2 electrons so that it will get 2 electrons. So total 8 electrons aa jayenge. All right. So if you had to draw the structure,
Ma'am,
Oxygen
8 or 4?
8 ना, 2 6 है, so it needs 2 electrons.
Okay, I thought you were telling about sharing. Okay.
Okay, so this oxygen will have 6 electrons. It needs 2 more, so it's going to share 2 electrons. The other 2 will remain as it is. This oxygen also in the same situation, it will share 2 electrons. So total, if I see, this oxygen has 1 2 3 4, and it'll take both the pairs 5 6 7 8, and same is the case with this oxygen also. So 1 2 3 4 and 5 6 7 8. So on paper, if you had to write, yeah, this is the Lewis dot representation. And otherwise, generally, this is how it is represented. Every line represents 1 pair. Oxygen is sharing 2 pairs, so you have 2 lines, O double bond O. This is weird. Like you write it a little closer, kind of looks like an equal to sign. So this is a molecule of oxygen. So these electrons that are shared, they are called bond pairs. So bond pairs are the pairs of electrons that are shared between the atoms, and the electrons that are not shared, upar like side mein jo bhi hai, they are called lone pairs because they're just alone, they're not shared. It's just terminology used, just make a note of it.
Miss, what is that lone pair?
Lone pair, LONE, like alone, lone pair. This is bond pair, BOND, because they're bonded. It is there in the bond, to bond pair. Lone pair is something that's like just chilling, which is not shared between the electrons. Just to identify, they're given names, the electron pairs. Like this has 2 lone pairs of electrons, this atom has 2 lone pairs of electrons, and molecule mein there are 2 bond pairs of electrons. You won't be asked, like in case you don't remember it also, it's okay. I'm just giving you information, like it'll make it easier if you're doing chemistry later on. Just be familiar with it. So done? Here. Similarly, work out nitrogen के केस में क्या होगा? Nitrogen exists as N2 molecule. तो यहाँ पे how are things? So if you want to figure out structure क्या होगा? First step, write the electronic configuration. Based on that, you can figure out कि अच्छा कितने electrons चाहिए, तो how should I distribute it? Like which 2 atoms should share so that all the atoms are satisfied. So that way you can kind of get an idea. And then based on that, you can write this thing, structure. And you can also note down, because there are 2 pairs shared, oxygen may, there is a double bond. Awesome. Mansi, Tanisha have figured it out. Like, draw the structure. So are you guys able to figure out like how to draw like dot representation mein, how to draw the structure? Awesome. Ananya has also got it. Absolutely. Yes, Elena also got it. So do it, work it out on your own. If anyone wants to, like, I'll just give you guys 2 minutes and then I'll do it on the board and you can check it. Agar kuch difference hai to correct it. Otherwise, yes, you guys got it. We'll be practicing more. Like abhi tak we've been doing simple molecules like H2, O2, N2, SA. Going forward, we'll look at molecules that have like different atoms and multiple bonds and all that. So as always, start with writing nitrogen would be 2,5, which means that octet ke liye figure out how many electrons needed. उसके हिसाब से करें. Oh, Anirban sent it on WhatsApp. Oh, Anirban, you sent for oxygen. Upar you started off with nitrogen, but uske baad you put oxygen. And when you're writing it, put it slightly close by. Okay, that will be clearer ki haan, they're both sharing the electrons. The way you have drawn abhi, Anirban, no, you did not draw it properly. So एक oxygen के पास 6 electrons है, the other oxygen by default 8 electrons है. That's not possible, no? Total 8 plus 8, 16 होना चाहिए, but you have drawn 1, 2, 3, 4, 5, 6 plus 8, 14 electrons only. So oxygen ka I've put it on the board, so you can just check that, compare it and correct it. Mansi also has sent it. Mansi, okay. You drew it in such a way that there is a triple bond, but there's a lot of extra nitrogen atoms, a lot of extra electrons there. See, nitrogen 2,5 matlab har ek nitrogen ke around 5 electrons hi hona chahiye. Right now I can count 1, 2, 3, 4, 5, 6, 7 electrons around each nitrogen, which is not correct. See, 2,5 na, which means you guys have identified 3 electrons are needed for octet. You guys have also mentioned that triple bond hona chahiye, which is absolutely right. But drawing mein you guys are facing an issue. Okay. So 5 electrons, right? And then if you also know that there is a triple bond, there will be 3 electrons shared between both the nitrogen. Abhi, these 3 dots belong to this nitrogen. Total 5 hona chahiye. So this means that only 1 lone pair will be there. Remaining only 2 electrons will be there. Same will be the case with this nitrogen as well. Remaining only 1 pair of electrons. So after you draw, you can also check हर एक atom के लिए. If I'm saying 5 electrons total, do I have 1, 2, 3, 4, 5? इस nitrogen के लिए भी there are 5 crosses, 1, 2, 3, 4, 5. Okay, so that part you need to be a little careful about. Anirban, you said nitrogen 2, 5, but you've drawn 6 electrons around each nitrogen.
Yes, now I got it.
Huh.
Earlier I was wrong.
Correct it. Correct what you said. And then when you're drawing the circles, you need to show इस nitrogen के पास 8 electrons है, तो वो 8 electrons कहाँ से आ रहे हैं? So it would be 5 of the original electrons plus these 3 particularly of the shared electrons. Similarly, if I consider this nitrogen atom, how is it satisfied? So 5 of the original electrons plus these 3 of the 8 electrons. So common between both these circles are these 6 electrons. So that's N triple bond N.
Can we do one more?
Yeah, we'll be doing a lot more of these. Just let me know when you guys have noted it, then I'll do the next one. Yes. What you've sent now, that is correct. You're literally showing कि atoms में electrons कैसे share हो रहा है. So if I'm saying 2, 5, the inner electrons we ignore because they're just chilling inside. There are 5 outer electrons. You need to clearly show that there are 5 outer electrons for each atom, and then show like how they are shared. Show double bond में या फिर triple bond में या single bond में, that way.
Ma'am, I got disconnected a few minutes ago. What were you doing?
Now I was just doing nitrogen ka hi. Just like see if you've gotten it, Shakti. Otherwise,
Ma'am,
Ananya, sorry.
Yes, ma'am, I sent you the answer.
Like you sent triple bond, but drawing, like, do you know how to represent the electrons? Kitne electrons kaise represent?
Yes, ma'am, I did that. Like how you did it, I would.
ठीक है. Anyway, we'll be doing more of this. How many of you are done up to nitrogen? Raise your hand, let me know, or you can send your working on WhatsApp. Then I can see agar sahi kiye ki nahi kiye, you can address it. Okay, 7, 8 people done. Nikki is also done, 9. Ananya is done, 10. Dhruv, okay. Rishita is also done. All right. So Ritvik, Snehal, Abhishek, Neil, Aditya, Abhishek is also done. Okay. Divya, what happened? Joined Abhi?
Yes, ma'am.
No, kya hua? You joined pretty late.
Ma'am, actually, I was not at home. I just came at 4 o'clock at home.
Oh, okay. So we started carbon compounds. Like abhi tak jo bhi kiya, like catch it on the recording.
Yes,
Since
the recording.
Okay, and since you've done it in school, like how confident are you feeling with covalent bonds, like whose dot representation, all that?
Ma'am, you could say like 7 on 10. Not, I know the concept, but sometimes in the difficult like that I get.
Okay,
Yes.
so that's what we're doing now. We'll be practicing this quite a bit. So yeah. Snehal, Ryan, Neil, Amey, what's up, you guys, and Tanisha? Where are you guys stuck? क्या हो रहा है? Just Nehal is done. Okay. You're done. Okay. All right. If you're stuck somewhere, if you have a doubt, let me know. Otherwise, we can move forward. Okay. All right. Next compound. Let's go with water only. This is fourth one. Water का formula क्या है?
H2O.
H2O.
So it's made up of 1 oxygen and 2 hydrogens. So we're stepping it up. Abhi tak we've seen molecules that like 1-on-1 molecules. Abhi there's like it's a triatomic molecule. 3 atoms है इसमें. So when you have this kind of a case, again start out by writing the electronic configuration. दो ही elements है, makes it easy. You have hydrogen and you have oxygen. Hydrogen का electronic configuration क्या है?
1.
1. Oxygen?
2-6.
2-6.
Right. So hydrogen needs like 1 electron more. Oxygen needs 2 electrons more. We see that water conveniently has like 2 of the hydrogen atoms. So how do you think they're going to share their electrons?
And how we are getting that this element needs this electron more?
Valence. So the aim is to have 8 electrons. Okay. Hydrogen is a special case क्योंकि एक ही shell है ना, तो पहला shell can accommodate only 2 electrons. Like remember 2, 8, 8, 18 and so on. तो पहला shell needs 2 electrons. उसमें से एक electron hydrogen के पास है. So it needs only 1 more electron. Oxygen दूसरा shell में 6 electrons है. This one needs 8 electrons total. So 8 minus 6, 2 electrons are needed. So that's how you figure it out. Octet configuration. Okay. So,
Okay, ma'am.
so how do you think the sharing will take place? तो ऑक्सीजन के लिए 2 इलेक्ट्रॉन्स चाहिए. कहाँ से आएंगे वो 2 इलेक्ट्रॉन्स? रिशिता? Yeah, Rishita, how would you distribute electrons so that all the atoms are happy? Rishita, 2 atoms of hydrogen, 1 of oxygen. Yes, correct. I mean, that's how you have like 2 hydrogen, 1 oxygen hai. Makes sense. So will they be distributed like this? Like how exactly should I arrange them?
HOH.
HOH, awesome. Yes. So oxygen will be in the center and both the hydrogens here. What kind of bond will there be between this hydrogen and like the first hydrogen and this oxygen? So I'll represent oxygen with blue and hydrogen with red. Okay. Anirban, yes, covalent, correct. So how many electrons will be shared between the first hydrogen and oxygen? Will they share? Will they have a double bond? Will they have a single bond? Yes. Ananya, Mansi got it. Elena got it. Yeah. So hydrogen will share its single electron and oxygen Anirban, you said double के लिए you need 2 pairs of electrons, right? मतलब, but hydrogen has only 1 electron, so double bond के लिए it doesn't have enough electrons. So always remember. Rishita, yes, 2 single bonds is the correct answer. So Anirban, if there is only 2 electrons being shared, so 2 electrons, matlab 1 pair of electrons, so this is single bond. If both of them are sharing 2 pairs of electrons, like total 4 electrons hai bond mein, so this is 4 electrons, matlab 2 pairs of electrons, tabhi this will be a double bond. And then if there's 3 pairs of electrons, so that's a total of 6 electrons. So that's like 3 pairs. And the result is going to be a triple bond. So if you're saying double bond, matlab you need to have 2 pairs. Matlab atom A and atom B. Atom A has to give 2 electrons, atom B has to give 2 electrons. In this case, hydrogen के पास एक ही electron है ना, तो it doesn't have 2 electrons to share. तो hydrogen कभी double bond बना ही नहीं सकता. Like hydrogen, double bond is impossible in the case of hydrogen. ठीक है?
Okay,
So,
ma'am.
ma'am, it will make 2 single bonds, right?
2 single bond, yes, with each hydrogen. So this is what it's going to look like. And oxygen should have 6, right? 1 electron here, 1 electron here it has given for sharing, and remaining 4 electrons will be lone pairs that oxygen will have. So oxygen has a total of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen also have their pura octet. Like in this case, it's a doublet because fully filled hone ke liye it just needs 2 electrons. This is what water looks like. So if you had to write it on paper, it is H single bond O single bond H. All right, once you're done with water, figure it out for methane. Let me know when you're done with water and then I'll discuss next one.
Ma'am, even methane is formed like this. Like,
Yeah, I'll be like, let's finish up water. Let's see if when everyone's done with water, then we'll look at methane.
Okay.
And okay, Aditya is ready. Ananya also, I'm guessing, is ready. Yes, let me know when you're done. Please don't just like keep sitting like that. All right, Mansi is done, Alina is done. Because your video is also not on, right? So I don't know what you're doing on the other side, whether you're noting it down or you're done. Tanisha, okay, Anirban, yes. Ritvik, okay. So Abhishek, Abir, Amey,
Yes, ma'am.
right, Sarah is done. Abhishek is also done, Bhavika is done. Dhruv, Divya, Ryan, Shakti, Vasudha.
I'm done now.
Okay. All right. So, do you know what is methane? Have you heard of this word before?
Yes, ma'am.
Yes.
CH4.
CH4.
Nice. Awesome. Makes it easier. CH4 consists of 1 carbon and 4 hydrogens. So, इसका structure कैसे होगा? Same. Hydrogen 1, carbon would be
2 and 4.
2, 4. Okay. Do you guys want to do this on your own or should I discuss it online?
We'll discuss.
Discuss? Okay. Hint. Okay. The method is like logic is the same thing. Hydrogen, how many electrons are required?
1.
1.
4.
1.
के लिए you have 4 electrons required. So imagine you have 4 hydrogens with 1 electron each. And you have like a carbon atom which has 4 electrons in its valence shell. So how do you arrange these 4 atoms?
Carbon in the middle and hydrogen in the 4 directions.
So how many electrons shared between each?
Like a plus sign.
Sure, but how many electrons shared?
Electron shared.
1.
1 electron each.
Where?
So 1 on top, 1 on down, then left, 1 right.
Correct. So 1 pair of electron shared between each thing. There you go.
Ma'am, I have a doubt.
Yeah.
Ma'am, why in carbon there are 4 instead of 4 there could be 2?
Sorry, I didn't get you. Can you repeat that, Anirban? Why in carbon?
Ma'am, in carbon you have written 4 electrons, but I think it would be true. It would be 2.
2. You're saying carbon may there should be 2 electrons.
Yes, ma'am.
Why?
Because in the water I asked you, then you told me that the first cell only means in hydrogen you have written 1 electron, in oxygen you have written 2 electron. That's why.
No, in oxygen we wrote 2 electrons because valence shell में there are 6. So octet complete करने के लिए you need to add 2 more. इसलिए 2 electrons are needed. So carbon में valence shell में there are 4. तो अगर 8 electrons चाहिए तो how much more should you add? How much does carbon need?
Okay, ma'am, 4.
Yeah. तो हमेशा bonding में ignore this. Ignore this. Inner electrons से कोई काम ही नहीं है. You only need to look at outermost shell में कितने electrons है और कितने चाहिए. Okay. So yeah, this is the structure. So each hydrogen gets its 2 electrons and carbon has its 8 electrons by sharing 1 each with each hydrogen. Guys, this is right at the bottom and it's cramped. If you want me to draw it properly, actually, let me just draw it properly. So you have carbon in the middle, 1 electron each. Then hydrogen. So this is hydrogen share. This is this one. This is here and this is here. And carbon is all 8 electrons together.
Again, I'm feeling one doubt.
Yeah.
Now, just now you explained me that if a C4, then we have to take 8 electrons, we have to do 4, we have to add +4. And why in hydrogen it will lose only 1 to 7, right?
हाइड्रोजन के केस में how many shells does hydrogen have?
1.
एक शेल है ना, तो वो
Yes.
that one shell, पहला shell can take how many electrons?
Only 1.
नहीं, हाइड्रोजन में there is one electron, but capacity क्या है? Like maximum number कितने electrons ले सकता है that first shell? Do you remember?
1.
नहीं, grade 9 में you studied ना 288, like maximum capacity is 2n square. You studied this, right? Do you remember that?
Yes, ma'am.
तो उसके बेसिस पे पहला शेल कितने इलेक्ट्रॉन्स ले सकते हैं मैक्सिमम? 2 इलेक्ट्रॉन्स, इसलिए सो हाइड्रोजन हैज 1. सो हाइड्रोजन का फुलफिल होने के लिए इट नीड्स टोटल ऑफ 2 इलेक्ट्रॉन्स. इट ऑलरेडी हैज 1, तो हाइड्रोजन नीड्स 1 more. So that's the logic.
Okay, understood.
So this is only for hydrogen. So hydrogen will aim to get helium ka configuration. Only hydrogen total 2 electron के हिसाब से लेना चाहिए. Every other element that you have, oxygen, carbon, nitrogen, fluorine, chlorine, like sulfur, like all of them will aim for 8 electrons. Yeah. All right. So once you're done with methane, figure out the structure for ammonia. Do you guys know what is ammonia?
NH3.
NH4.
NH4 is ammonium ion, which is derived from ammonia, जिसका formula है NH3.
NH3.
Yeah. So what is the, figure out the structure. Like, as always, nitrogen is the central atom surrounded by hydrogens. Let me know how many single bonds, how many double bonds, how many triple bonds will be there in ammonia. Once you've figured out the structure, let me know like how many single, double, triple. Send the answer on chat. Like, I want to see answer from everyone. A lot of people who are like really quiet today. Send it on chat. Nice. Elena got it. Puneet, no. Think about it. Nitrogen hai, okay. Nitrogen is bonding with hydrogen. Rishita got it. That is correct. So Elena and Rishita are the only ones who have figured it out abhi tak.
What do we have to tell in the chat?
Structure. Tell me in terms of how many single, how many double, how many triple. Mansi got it. That is correct. Elena, Rishita, and Mansi. Vasudha, I don't get it. Bond jo hota hai, it is between two atoms. So if you write N single H triple, that is not making sense to me. Tanisha got it. That is correct. NH के बीच में bond होता है. So it could be a single bond, double bond, triple bond. That's what you need to figure out. Now, Jaden, Abhishek, Anirban, you all have sent the same answer. That is not correct. Mansi and Anirban have sent structure. Let me see. Mansi, electronic configuration is correct. Mansi, yeah, like you sent the right answer also. Your structure is also right. Awesome. You got it, Mansi. Well done.
Thank you, ma'am.
Anirban, like you just put N all around, like nitrogen bhi hai, hydrogen bhi hai. You have both the things, no? You haven't gotten it. Okay. So start by writing nitrogen ka configuration kya hai?
And 2, 5.
2, 5.
Nitrogen ka configuration?
1.
1, yes. So nitrogen, what, like how many more electrons does it require? Abhishek? Octet fulfill करने के लिए. Anirban got it, yes. Ananya, like aim, like you need 8 electrons. Nitrogen के पास है 5. तो total कितने चाहिए? So nitrogen requires 3 electrons. So you can like draw mini nitrogen also here. Nitrogen के पास है 5 electrons. So it requires like 3 more to complete octet. Hydrogen, how many electrons does it require?
1.
Hydrogen requires 1 more electron. Hydrogen always requires 1 electron. So ऐसे NH3 मतलब you have 3 hydrogen atoms, एक single electrons के साथ. So how do you mix and match so that nitrogen gets 3 electrons and hydrogen का भी fulfill हो रहा है? Like how do you mix and match this? How do you arrange it?
Nitrogen in middle first. Then I have done like hydrogen on top, left and right.
That's how you've drawn it. But how many electrons shared between each?
Single.
Single pair of electrons shared between each. So see, nitrogen requires 3. You have 3 hydrogen with like 1 electron each. So if each one gives nitrogen its own electron, like share ho jayega na pura. So 1 electron from this hydrogen, 1 from this, 1 from this. Then nitrogen has its own 5 electrons. Like if it requires 1, it needs to give 1. So pair complete kar lo. Total 5 होना चाहिए. 3 are sharing with each hydrogen. So remaining 2 are there over there chilling. So this is the structure of ammonia. So you can see nitrogen is center. इस hydrogen के साथ single bond है. इस hydrogen के साथ it has a single bond. With this hydrogen it has a single bond. तो total कितने bonds है ammonia में?
3 single bonds.
3.
3 single bonds. Yes. A lot of you have sent triple bond. So triple bond का मतलब N is sharing 3 electrons with the same atom, which is not happening here. It is sharing 1 electron each with different atoms. So you need to be careful. Like even though nitrogen has 3 bonds, this is not a triple bond. अगर 3 bond एक ही atom के साथ है, then it is a triple bond. अभी 3 अलग-अलग atoms के साथ है ना? Yeah, they are all hydrogen, but there's still 3 different atoms of hydrogen. So this, like basically the answer I was looking for is nitrogen has 3 single bonds. You can see that single bond 1, single bond 2, single bond 3. Make sense? Guys, got it?
Yes, ma'am.
Yeah, ma'am.
Yes.
What other thing can we do? So Vasudha, Abhishek, Jaden, you guys got it? Clarified? Clear about this? Guys, yes or no? How's it going? All right, whoever has done like completed ammonia, the next one, 7, do it for carbon dioxide. You know the formula for carbon dioxide?
Yes, ma'am.
CO2.
CO2.
CO2. Excellent. So, you know, there is 1 carbon and 2 oxygen. See how you can distribute it so that all the compounds get the same thing. Nice. Neki got it. Puneet, yes, you also got it. Cool. Now you guys are getting the hang of it. Elena, yes, you got it. So Neki, Puneet, and Elena have gotten it. Anirban, no. थिंक अबाउट इट ना, लाइक अगर 2 एटम्स है, लाइक 3 एटम्स है, तो मिनिमम 2 बॉन्ड तो होना चाहिए, आइदर 1 सिंगल 1 डबल और 2 सिंगल और 2 डबल या फिर 2 ट्रिपल. Like use logic, Anirban. Like think about it. Ritvik, yes, you got it. That is correct. So far, Ritvik, Elena, Puneet, and Neki have gotten it. Aditya, so if you say 1 double bond, like ठीक है, एक कार्बन और कोई भी एक ऑक्सीजन के साथ ये saying like a double bond है, या फिर 2 ऑक्सीजन के बीच में एक डबल बॉन्ड है, तो वो तीसरा एटम क्या हो गया? So you have 1 carbon and 2 oxygen. So that's what I was telling Anirban also, Aditya. You need to have a minimum of 2 bonds, whether it's 2 single, 2 double, 1 single, 1 double, or 2 triple, or 1 double, 1 triple. Minimum 2 to hona chahiye to connect all 3 of them. Mansi, हाँ, abhi you've corrected it. That is correct. Anirban, again you sent triple. तो अगर इन दोनों के बीच में एक ट्रिपल बॉन्ड है, तो तीसरा एटम क्या हो गया? Neki, you've sent the structure on chat. Brilliant. That is correct. So Anirban, I'll work with you on this. Like, how are you approaching this? Bhavika got it. Yes. Chalo, Anirban, like, how are you approaching?
Yes, ma'am. Ma'am, for carbon dioxide, the formula is CO2. So I took carbon is equal to 6 and oxygen is equal to 8.
Atomic
First step.
number है 6 and 8. ठीक है.
In carbon, I wrote a dash 2 electron needed.
How?
Ma'am, 8.
6 electrons are the total number of electrons carbon has. But 6 electrons, like, you need to write the electronic configuration. That's where you're getting a mistake. So nitrogen has total 7 electrons, but how are the 7 electrons arranged? All 7 are not just there randomly, right? They're distributed properly. Like pehle shell mein there's 2 electrons, dusre shell mein there's 5 electrons. So that's why, क्योंकि outermost shell में 5 electrons है, we decided that अच्छा, like total 8 चाहिए, मतलब we figured कि 3 electrons are required. Similarly, carbon के case में 6 is the atomic number. This is the total number of electrons that carbon has. So how are the 6 electrons there in carbon atom?
Ma'am, it is 2, 4.
2, 4 ना, so this is what you need to consider. 2, 4 है, तो पहला shell में 2 electrons है, completed है, we ignore it. So 4 is what you need to focus on over here. And क्योंकि 4 electron है outermost shell में, so how many more are required?
4.
So 4 more electrons are required by carbon. Okay. So similarly, you'll do the same thing with oxygen also. You don't take 8 directly. Write the electronic configuration first. This is the important bit. Okay, so yeah, like now work it out based on the electronic configuration and then let me know.
Okay, ma'am.
In the meantime, Abhishek, Bhela wala, like such a thing does not exist. Something called a quadratic bond doesn't exist. But the answer that you sent afterwards is correct. Okay, who else? Abhishek has sent the answer. Abir, what's happening? Are you able to get it? क्या हो रहा है from your end?
I got it.
तो भेजो ना आंसर. If you've drawn it, you can send the structure on WhatsApp or at least send the answer here on chat. Aditya, I think, has already sent it. Yes. Amey Sonkhasकर, क्या हो रहा है? Mansi, structure is absolutely right. I can see there's an extra electron on carbon. I don't know if that's erased or if that's there, but that shouldn't be there. But otherwise, rest of it is all right.
Yeah, ma'am, it's erased.
ठीक है. Tanisha, no, try again. Kind of close, but not correct. Deshna, I have not heard from you at all this session. क्या हो रहा है? You getting it?
Yes, I'm doing it.
Okay. So send the structure. Either you can send it on WhatsApp if you've already drawn it, or at least send the number of bonds on chat. Bhavika also got it. That is correct. Elena has sent. Jaden, Ryan, Rishita, where are you guys at? So Ritvik, Snehal, you guys also have not sent it. Vasudha, like, did you get carbon dioxide? You getting it? Yeah, okay. No, Vasudha has already, no, who is it? Ritvik has already sent it. That is correct. Okay. So I'll give you guys a hint. Double bond is correct. Tanisha and Anirban have now sent ki double bond hai. But kitne double bonds hone chahiye?
Ma'am, 4.
4 double bonds. So on all sides of carbon, do you think this is how it is? Think about it. Agar 4 double bond hai carbon pe, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 electrons hai. Yeah, it's like too much. हाँ, अभी Tanisha, Ananya, Rishita, and Deshna have sent it. You guys got it. That is correct. So Anirban, like, imagine it's like trying to play with building blocks, I guess. See, carbon is capable of forming 4 bonds. Okay. So there's 4 attachments to carbon. So either carbon can do like 4 single, or carbon can do like 2 double, or you can arrange it as, you know, a triple and a single. Basically, 4 connections hai, you can arrange it however you can, like however you want, you can arrange it. Now oxygen is 2, 6. 6 electrons matlab octet ke liye it needs 2 more electrons. So that means oxygen can form 2 bonds. So agar ek oxygen atom hai, the 2 bonds, it can either have 2 single bonds this way, or it can do like 1 double bond this way. Now imagine you have these 4 block pieces. How can you arrange 1 carbon atom and 2 oxygen atoms such that all of their connections are like fulfilled? Carbon gets 4 connections and oxygen gets 2 connections. How will you do that?
We will make dots, Lewis dot.
Yeah. Like either you can, like, so 3 hai na, so which one will be in the center, oxygen or carbon?
Ma'am, carbon.
Carbon is in the center and oxygen will be on other sides. Okay. दो oxygen है, एक carbon है. Now, how many bonds between each of these so that they have पूरा octet? Let me just draw it cleanly. Carbon in the center, and then you have two oxygens. तो पूरा octet के लिए, how will you distribute the electrons? See, carbon needs 4, oxygen needs 2, and then you have 2 of these oxygen atoms. So how will you distribute it?
Ma'am, we will make 4 on carbon, like one side 1 dot, left side 1 dot. This way.
So, okay, if I make it that way, so एक dot के साथ, okay, this is sharing with oxygen. Now, what about these 2 electrons? तो total फिर मेरे पास होगा, अगर ये कार्बन एक इलेक्ट्रॉन शेयर किया इस ऑक्सीजन के साथ एंड एक इलेक्ट्रॉन शेयर किया इस ऑक्सीजन के साथ, then I have a total of 1, 2, 3, 4, 5, 6 electrons only. And oxygen का भी fulfill नहीं हो रहा है. If it's getting only 1 out of the 2 electrons, then it will have 7. 8 नहीं बन रहा है ना.
Yes.
So what then? How will you distribute it? So in this case, carbon will form 2 double bonds. See, 4 electrons hai. Oxygen needs 2 electrons, and there are 2 oxygens. You can write another one. Oxygen 8, 2, 6. It needs 2 more electrons. So if carbon shares like 4 electrons jo hai, if it distributes it among both the oxygens, then the oxygens are also fulfilled, and carbon is also getting like 2 electrons each from each oxygen. Na? बन गया carbon की 8. And then oxygen का भी check कर लेते हैं. 2 it is already sharing with carbon. So 6 में से if it's sharing 2, remaining 4 are there. So out of 6 are its own, and then it's sharing 2, so it's getting 2 from carbon. So बन गए oxygen के भी 8 electrons.
Okay, ma'am.
Yeah. So Anirban, you'll need like a lot of practice in this. I'll see if there's like a game, like a simulation or a video that you can use to practice this. So this is how the structure of carbon dioxide is. Carbon is in the center, 4 electron shared, so double bond over here, double bond over here. So 2 double bonds are present in a molecule of carbon dioxide. Okay. I know some of you have already gotten it. You have sent the answer. Some of you are like getting it. I know that you're trying, but others I have no idea. Like you answer yes, khatam ho gaya and all that, but like I don't get any answer from you. So I don't know if you're doing it correctly or not also. So yeah, you guys need to talk. You need to respond to me. Tabhi pata chalega. All right. More practice covalent bonding ke liye, or should we? Actually, it's 4:55 now. We'll do a couple more and then we'll end the session here. Or yeah, we'll go with an easy one. This is question 9. Hydrogen.
Ma'am, can we do an example of triple bond now?
Okay. Do hydrogen fluoride. After that, I'll think of an example with triple bond. Like, yeah. Hydrogen fluoride ka, what is the Snehal, 5 minutes. Now we'll end the class in like 5 minutes. This will get done at 5 o'clock. All right, hydrogen fluoride का formula क्या है?
H2F.
Hydrogen fluoride. H2O is water.
HF.
Fluoride. Fluoride आएगा fluorine से. And fluorine is F, na? So this is HF.
I told H2F.
H2F. Acha. Fluorine ka valency is -1. It is very, very similar to HCl. That's a big hint for you right there. So yeah, formula is H2F. Sorry, HF, not H2F. Because hydrogen ka valency is also 1, fluorine ka valency is also 1. So single, like it's 1, 1, so it's HF. Ha, yes. Abhishek, that is correct. Tanisha also got it. And Elena also got it. Mansi, like there's only 2 atoms. So एक ही bond होगा. So I'm looking for if it's a single bond or a double bond or a triple bond. Aditya, Annie got it.
Atomic number of fluorine.
Anirban, yes, he got it. Abir got it. Awesome. Neki got it. Sandhi structure also brilliant. So hydrogen has 1 electron. Fluorine, everything is exactly like Cl. Rishita got it. And total 7 hai na, 6 more are right here, just like fluorine. So H or F ke beech mein, we have single bond. So this is the structure of hydrogen fluoride. All right. You guys.
No, I think working also, which correct?
You send it on WhatsApp, no? I'll need to check 1 minute. You didn't send it. Where did you send your working? Acha, haan, abhi aaya. Again, see, formula is HF, matlab you have 1 atom of hydrogen and 1 atom of fluorine. But what you have drawn is center mein hydrogen hai or left side, right side fluorine mein hai. You've drawn 2 atoms of fluorine, which is not correct.
Okay, ma'am.
Yeah, this is the 1 atom of hydrogen and this is the 1 atom of fluorine, HF. Bas utna hi hai. See, the Lewis dot representation is the exact visual representation of the formula. Like formula may you write it in the shortened form, you just show how many atoms or kaun se atoms hai. Dot representation, you will spread it out and you will show how are they. So if you look at carbon dioxide, CO2 matlab CO2 represents 1 atom of carbon, 2 atoms of oxygen. So you can see there is 1 atom of carbon and 2 atoms of oxygen. Yeah. All right. So after this, work it out for hydrogen cyanide. This will be like your homework. Formula is HCN. This is your cyanide pill ka. The cyanide is the same cyanide. So this is called hydrogen cyanide. Yeah. I'll discuss this back in the next class when we meet for the next class. But yes. Yeah. Work it out for this and we'll end the session here.
Next Friday will be a different chapter.
No, we'll continue with carbon compounds only. This is going to take a couple of classes. And there might be a change in the next schedule. Okay.